Assalamualaikum and very good day. Today we will discuss about hydraulic gear pump spur gear. We will proceed to the first part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Hadi Nasrullah bin Mustafa Kamal with nomenclature B092110018. Today I will introduce about what is gear, types and classification of gear, and law of gearing. What is gear? Gear are mechanical components that transmit rotation and power from one shaft to another when each shaft has properly shaped protrusion evenly spaced around in circumference so that the following tooth penetrate into the space between the teeth of the other shaft. A gear train consists of two or more gears connected in series. It is used to increase or decrease the output shaft speed or torque. The term of gear ratio is used to calculate the speed and torque of the output gear when the torque is applied to the input gear. Types and classification of gear. From the table we can see we have 3 classification and 6 types of gear. First, parallel axis, 2 parallel shaft. For example, spur gear and helical gear. Second, intersecting axis, 2 perpendicular shaft that intersect. For example, bevel gear and meter gear. Third, cross axis, 2 perpendicular shaft which does not intersect. For example, worm gear and rack and pinion. Law of gearing. The gear law states that the angular velocity ratio between machine gear always remains constant. In general, to achieve the constant angular velocity condition, normal at the point of contact between the mating gear teeth always go through the pitch point, where the pitch point is the contact point between the pitch circle of the mating gear. If the angular velocity of mating gear is constant, it can conclude to the following relation. So from the picture we can see the relation. Why is law of gearing important? The gearing law must be followed so that the two gears can transmit motion from one to the another with a constant angular velocity ratio throughout the gear mesh. Thank you, that's all.
Assalamualaikum and very good day. I'm Muhammad Ahmad bin Anwar and I will present about the gear selection and the working principle of the gear. So the gear that we has choose is the spur gears. As we know, the spur gears is used for a wide range of speed ratio in a variety of mechanical application. Example of the application is a hydraulic gear pump. For the working principle of the fluid, first, the fluid enter the pump on the suction side. Second, as the gears on the suction side rotate, the volumetric space between the gear teeth increases. Fluid enter the space cavity between the teeth due to the negative suction pressure within the cavities. As the gear rotate further, fluid within the cavities become trapped between the gears and casing. After further rotation, the gear approach the discharge size and the gap between the gear and casing increase and the fluid escape from the cavity. Then the process is repeated. That is how the spur gear on hydraulic gear pump is working. We will go to the gear design. During the improvement, we will improve this gear design. Changes of gear teeth and gear shape will affect the speed of the gear and fluid flow. This gives more efficient to the working process. The gear design improvement are shown in a discussion section and it will proven during the calculation part later. So you can see the animation of the gear rotations. So that's all from me. We will go to the next part. Thank you.
Hi everyone, my name is Yap Xiaoming and my metric number is B0921102113 and I'm from the course BMMM and this is the part that I'm going to present. It's a calculation part. And on the left hand side, it is the free body diagram of the hydraulic gears. The gears consist of two gears, which is the driver gears and the driver gears. And the arrow shows that the rotational directions of both gears. And for the dimensions, the both gears have 12 teeth, 35 millimeters of outer diameters, and 24 millimeters of inner diameters. And both gears have 7.3 millimeters of pitch. Firstly, we are going to calculate the gear ratios. The gear ratio can be calculated by using these formulas. The gear ratio is equal to the number of teeth of the driver gears divided by the number of teeth of driver gears. And since we know that the both gears have the same teeth, and the gear ratios calculated is equals to 1. Hence, we can calculate the rotational speed of the driving gears using these formulas, because we know that the gear ratio is equal to 1 and the rotational speed of the driver gear is equal to 1800 rpm. Therefore, the rotational speed of the driving gears is calculated and is equal to 1800 rpm. As the gears have the same size and the number of teeth, therefore, we would expect the two gears will have the same rotational speed, since they have the gear ratio of 1 to 1, and this is only valid when the losses during transition of energy is not taken account, which means that we ignore the frictions during the operations. Hence, to calculate the inlet power, we assume that the input torque is equal to 80 Nm, the torque of the driver is equal to 80 Nm, and hence the inlet power can be calculated by using these formulas. The inner power is equal to 2 pi multiplied by the rotational speed of the driver gears, hence multiply with top of the driver gears, hence divided it with 60. After that, we can get that the inlet power is equal to 16.08 kilowatt. Hence, if the gears is operating at a efficiency of 85%, the outlet power can be calculated by using these formulas. The gear efficiency is equal to outlet powers divided by the inlet powers, and hence the outlet powers is equal to 12.82 kilowatt. And by getting the outlet power, we can calculate the outlet torque, and hence the outlet torque is calculated and it is equal to 68.01 Newton meter. And I think that's all for my part. Thank you.
Okay, next is discussion. Is about the improvement of gear selection. Me, Faim Farhana binti Abdul Manan, we discuss with you about the gear selection. Okay, firstly, the improvement is dimension of gear, which also known as gear ratio. The higher gear ratio of a faster acceleration, while lower gear ratio of a higher top speed. In addition to the gears in transmission, the rear differential also has a gear. As a result, a gear rotational speed decreases with increasing radius. Two gears teeth meshing together causes the gears to rotate at the same speed. The circumferential speed of a wheel or circle divided by the radius determines the rotational speed. Next, the improvement can be made by changing the teeth gear. For every rotation of the medium wheel, the large wheel completes approximately 2/3 of a rotations. Always the smaller wheel, the one with fewer teeth, will rotate more quickly than the larger one. Besides, the material of gear affect the efficiency. For hydraulic gear pump, cast iron and stainless steel are suitable. It is because cast iron generally has excellent pressure ratings because to its durability, abrasion resistance, and strength. While stainless steel has a greater pressure rating than plastic and protects the pump components from chemical and rust damage. Okay, last but not least, the gear tooth shape can be improved by external gear pump design. An external gear pump uses two identical gears that are meshed side by side, of one which is driven by a motor, drives the other gear, drives the idle which is the driven. A shaft with bearing on both of the gears supports each gears individually.
My name is Abdul Fattah Ifwa bin Ishaq. Metric card number is B0921101006. So we continue about the new design gear. This is an example of driver and driven. This is circle, driven and driver. Change that can be made to improve efficiency of the gear. Fluid can enter the pump on discharge side smoothly, increase the work rate of the gear and pump. Okay, next is conclusion. First one is the gear system can be used on equipment that transmit energy, water pump, soft, hydraulic pump, electric generator, and so on. Number two is gear are mechanical device that transfer rotation and power from one shaft to another, provide both have properly formed projection T. Number three, when two gear with a not equal number of T are combined, the mechanical advantage is obtained. The last one is every machine and or equipment that use gear need to ensure that appropriate gear size so that damage does not occur in a short period of time. That's all from use about hydraulic gear pump that use spur gear and made simple improvement to them. Thank you.